Okay, good morning to all. So we'll start the class. Okay, it's around 9:35. So we'll continue with the same topic, that is the starters. Okay, we already discussed about the different types of starters and what are the types of starters used for the squirrel cage as well as the Kipling induction motor. So next topic is the soft starting of three-phase induction motor. So in the previous starters, what we have discussed. Okay, so what is the soft starting means? So generally we discussed that the starter is used for some three purpose only. So limiting the starting current, so to eliminate the overload and the single phase. So other than that, so we have additional responsibility of the starter. So that is if you are doing some speed control means with the help of starters we can do the speed control also. That is if you want to accelerate, de-accelerate, and if you want to stop uh, the particular motor, acceleration, deacceleration, reversing. So these are the additional responsibility of the starter. So in the starter itself, these functions can also be carried out. Okay. So here, what is meant by soft starting means without any noise. Okay. Uh, and avoiding the mechanical contact. Okay. Suppose if we are consider in the start delta starter. So if you want to switch over from start to delta means so we will have some transition. Okay, we have some transition. So that is a that transition will take place through the uh, any switches. It may be triple pole, double throw switch, or triple pole, single throw switch. So switch or mechanical contact is involved in the normal starters. Okay, so if you are if you are changing the switch position from start to delta or from start position to run position, so this and all need a mechanical contact. So there may be a possibility of wear and tear, and there may be a possibility of generation of spark, and the mechanical contacts will get degraded. So due to arc formed in the contacts, um, it can get weakened, or the proper closing of the contacts cannot happen. So we'll have some problems related to the if you're having a mechanical uh, elements. Okay, so if you're having a isolator or switch, so that all considered as a breaking or making a particular portion of the circuit. So what is the role of this soft starting means? So this will be involved with normally open and normally closed contacts with the timer. Okay, so we have all the starters or what are the elements we are using for the changeover will be involved with the contacts. So what will happen? The noise as well as improper closing of the contacts, formation of spark, so everything can be avoided. Okay, so we will call this as advanced starting methods. Okay, so in conventional we have some starting methods that we discussed in the earlier classes. Okay, so advanced starting methods represents it includes some more additional functions, and it eliminates the disadvantages of the mechanical contacts. If you are changing from one position to another position, and if you are having a variac, so that everything will be avoided in the case of the soft starting. And we have acceleration property, de-acceleration property, stopping, reversing. So this additional property also can be incorporated in the soft starting method. Okay, so we'll discuss some more points. Okay, so it starts. You can see the slide. Okay. So once again. network இல்ல ஒரு 1 செகண்ட் வெயிட். நெட் கட் ஆயிடுச்சு போல. வந்துச்சு விடுங்க, கட் ஆகி வந்துச்சு. ஓகே சரி. யூனிட் டெஸ்ட் போர்ஷன் வந்து நான் டிரான்ஸ்ஃபார்மர் தான் பார்த்தேன். சிலபஸ் பாரு, கூகுள் கிளாஸ் ரூம்ல இருக்கும் பாரு. இண்டக்ஷன் மோட்டாருக்கு முன்னாடி டிரான்ஸ்ஃபார்மர்ஸ் இருக்கும் பாரு. ஆட்டோ டிரான்ஸ்ஃபார்மர், கன்ஸ்ட்ரக்ஷன் ஆப்ரேஷன் ஆஃப் ஆட்டோ டிரான்ஸ்ஃபார்மர். நெக்ஸ்ட் வந்து என்ன இருக்கும், 3 phase டிரான்ஸ்ஃபார்மர், ஆஃப் லோட் ஆன் லோட் டேப் சேஞ்சிங். ஸோ இது அது வரைக்கும் தான். ஆட்டோ டிரான்ஸ்ஃபார்மர், நெக்ஸ்ட் வந்து ஆஃப் லோட் ஆன் லோட் டேப் சேஞ்சர், 3 phase டிரான்ஸ்ஃபார்மர், 3 phase டிரான்ஸ்ஃபார்மர் கனெக்ஷன்ஸ். அவ்வளோதான். இந்த சிலபஸ் பார்த்தீங்கன்னா இண்டக்ஷன் மோட்டார் இப்போ நாகராஜ் சார் நடத்தின வரைக்கும், இப்போ நான் நடத்துறது வந்து இண்டக்ஷன் மோட்டார் தான். நாகராஜ் சார் வந்து செகண்ட் மாடியில் எது வரைக்கும் நடத்திருக்காங்களோ அது வரைக்கும் தான் சிலபஸ் வந்து யூனிட் டெஸ்ட் 1. ஸோ இண்டக்ஷன் மோட்டார்லேருந்து மாடியூல் 2 செகண்ட் ஹாஃப். ஓகே, வில் கண்டினியூ த கிளாஸ். ஹலோ. ஓகே. So these are the some of
sir,
the
audible sir.
Okay sir, okay. Net கொஞ்சம் கட் ஆயிடுச்சு சார் இங்க.
Okay sir, okay.
நடுவுல வரல கொஞ்சம். So these are the additional properties we are going to incorporate in the soft starting. That is a stop, reverse, accelerate, and protection. Generally, we'll have protection means we'll have the single phasing protection, overload protection, and so we have the contacts will be available that I already told. Okay. So what is the need for the soft starter? Okay. To avoid the overloading of power distribution system and to avoid unnecessary wear and tear on equipment by reducing starting torque. Okay. So this is the main purpose of the soft starter. So in the conventional starters, we'll use mechanical contacts. That is the switches. Okay. So if you see the auto transformer starter, we'll use the switches to change over from start position to run position. And similarly, if we see means in the star delta starter also again we have the changeover position from the star to delta. So this everything will be avoided in the case of the soft starter. Okay. These are the main two purpose of the overload, to avoid overloading. So that is the first point. It eliminates the overloading of the distribution system, and unnecessary wear and tear can be avoided. Okay. And these are the starters available in the case of the soft starter. So we will have a small modification in the already existing starter. So already we will have 5 different starters are available. So in that we are going to include this normally open and normally closed contacts. That in background we will have a timer. Okay. So these normally open and normally closed contacts will be controlled by the timer circuit. So these are the 5 types of starters we are going to discuss. Okay. So one is a primary resistor starter, auto transformer starter, part winding starter, and bi-delta starter, okay, and solid state starter. So these are the starters we are going to discuss. Okay. And the first is the primary resistance starter. What is the primary resistance means? It is otherwise called as a stator resistance starter. So what is the other name for primary resistance means? It is otherwise called as the stator resistance starter. And here you see the construction of the starter. So here we have the 3-phase supply will be given at the input side. So we have a 3-phase supply RYB L1, L2, L3, and this is called as the normally closed contact, and this is a normally open contact. Okay, so we have 2 symbols. So this is a closed, normally closed NC we call as a capital NC. Okay, and this is a normally closed, and this we call as a NO. Okay, normally open contact. And we'll have across the normal open contact, we'll have a resistor. Okay, we'll have the resistor, and then we'll have the fuse, and the next we'll have the terminals of the this we'll have the squirrel cage induction motor. So what is our objective? Generally, during the starting condition, we'll add the resistor, okay, in order to reduce the supply voltage. And when the motor attains the rated speed, what we'll do means we'll remove the resistor manually. So if you refer the stator resistance starter, and there is a conventional starter means we'll have the variac in the resistor. We'll have a variable resistor. Okay. And here we'll have a fixed resistor. So if you refer the stator resistance starter means we have the resistor like this, and we have a variac, okay, for the 3 phases. So we'll have the 3 terminals, we have a variac like this. Okay. And this we'll do manually. Okay. If you want to reduce the voltage means we'll move the rheostat manually, and when the motor attains the rated speed, we'll keep at we'll have a minimum position and a maximum position. So during the starting condition, we'll keep the resistor at the maximum position, and during the full running condition, we'll keep as minimum position. But here we are having a fixed resistor, refer the PPT. So we have the 3 resistors are connected across a normally open contact. Okay. So what is the role of this resistor means? So during the starting condition, so the supply will flow like this through this resistor. It will go, and it will enter into the windings. Okay. So once the motor attains the 70 to 80% of the rated speed, so what will happen means this resistor will be removed. This resistor will be bypassed. Okay, the supply will be directly go through this circuit. Okay, so this is the role. So initially we'll have the flow will be through the resistor. So once the motor attains its rated speed, what will happen? This contact will get closed. Okay, this normally open contact will get closed. So this everything will be controlled by the timer. Okay, we have the time settings. So once when the supply is entering, so it will have 10 seconds or 15 seconds. So within that, we'll have the changeover from start position to run position. So during the starting condition, this resistor the flow of the current will be like this: L1 and normally closed contact, and we have the resistor, and we have the fuse, and the supply will be enter into the 3-phase motor. Okay, and once it reaches the rated speed, what will happen? So this resistor will be removed, and this contacts will get closed, and the supply will be given to the 3-phase motor. So what is the time period allowed to change over from normally open contact? When the normally open contact will get closed means when the supply is given after 10 seconds or 15 seconds, then the flow will get changed. So here we are not having any movable part. So in the case of the stator resistance starter, that is in the conventional case, we'll have a movable part. We'll have a variac, we'll have a fixed terminal, we'll have a variable terminal. So if you want to adjust the resistance, you have to manually adjust the variac and you have to keep the position. So what will happen? There will be a possibility of creation of the spark. So due to spark, heat will be generated across the resistor, and there may be wear and tear. So if it gets aged, means what will happen? There will be a small gap between the resistor and the variac. So the gap is more, means the contact will not be proper. So at some phases you won't get a proper full voltage will not be given applied, will not be received across the motor terminals. So these are the problems we will face in the conventional starters. So in the case of this soft starter, we are not having a variable resistance. We have a fixed resistor will be connected. So across the motor, so the full resistor will be included when the motor attains its rated speed. Then the current path will be changed. The normally open contact will get closed. Okay, and next full supply will be given to the motor. Okay, so here in this starter, so no moving part is available except the motor. So except motor, what are the elements here we are using? All are static device. So this contact is static device, resistor is static. Normally closed contact and open contact all are static device. Timer is also static device. So no movable part or no variac is present in this circuit. Okay. So that is the difference between the conventional and the soft starter. Are you clear? And here you have to remember additional points, normally closed contact and normally open contact. So we will have the symbol like this only. So we will have the contact, this is the exact symbol. So this represents the open contact and this is the closed contact, normally closed contact. Okay. So this will be operated through the timer only. We have a timer. Okay. So based on this timer, in timer we can change the time period. The switching position can be changed by setting the time period. We can adjust the time also. Want to quickly start this motor, quickly want to apply the full supply voltage. You can reduce the timing to 10 seconds or 5 seconds. You can change based on your application or requirement. Okay. So that's the primary resistor starter. Okay. So second will be the auto transformer starter. So in the conventional starter, we are doing some modification. That's it. Okay, we are not doing any other thing. So here again, we'll have a transformer. Means in the conventional transformer, we'll have in the start position and the run position. So that is start and run position is changed as the current flow. Okay. Either you are including the resistor or you are removing the resistor. So like that, we are going to consider. So here, this is the winding, external winding you are going to use during the starting period. So we'll have a 3-phase winding. So here we'll have the positions. Okay. So full windings you are going to include means we have called as 100%, 80% you are going to include, 60 you are going to include, 50 you are going to include, or you are going to remove entire circuit. Okay. So these are the different positions or percentage of tappings. Okay. So if you are having 10 turns are available, so if you are including 5 turns, it is considered as 50%. If you are including the entire turns, means you will call as a 100% tap setting. Okay. And again here we are having the 3-phase input supply L1, L2, L3, and then this is a normally closed contact, this is a normally closed, and this is a normally open contact. Okay. Normally open contact. Okay. So when what is the role of this auto transform during the starting condition only we are going to include this tapping. Okay. And this transformer is connected short circuited. Other end is short circuited. This also normally closed, normally open contact. So we have at the input side and output side. So we have the normally open contacts. Okay. And we have 6 normally open contact and 3 normally closed contact. Okay. So when you are giving the at the normal condition, what will happen means, so if you are giving the input supply, what will happen? This this contact will get closed. Okay, this will be gets closed, and the supply will go to this winding. And if you are chosen 65% means, so it will go like this. It will go to the motor. So L1 and then we'll have a normally open contact. This will get closed, and then when the supply given, it will get closed, and if the position is at 65%, okay, the position is at 65, it enter into the winding, and it will go through this point. Okay, so this will be the normal case. And if you want to adjust, means if you are keeping at 50 position, means it will go through 50, and if you are keeping at 80, it will go through the 80. And once the motor gets the rated speed, then what will happen means, so this normally closed contacts will get energized. Okay, so here we have, if you're having a contact, means we have a energization and de-energization. And if it is energized, means suppose this normally open contact, so energization and the de-energization. So this will be controlled by, already I told, will be controlled by the timer. So in that we have the coil. What will happen? Energization. So if it, this contact gets energized, it represents that you are going to close this. Okay, this contact will get closed. So de-energizing, what will happen? You are removing the supply, means so it gets opened. Okay, that is the meaning for energization and de-energization. Okay, so when the input supply is given, so this normally open contacts will get energized and it will close, and we will have the supply flow will be like this. And once the motor attains the 70 to 80% of the rated speed, then what will happen? So again, the timer will try to open this contact. Okay, so normally open contact, and you will have the supply will flow. So like this. So it represents that you are removed the entire winding from the in motor side. Okay, it is connected in series with the motor. You are removed the entire winding. So full supply voltage will be given to the three-phase motor. Okay. So this changeover position again, it based on the timer. What is the time you are setting? Okay. Then once if you are suppose setting for 15 seconds, you are setting means after 15 seconds, what will happen? This contact will get open and this will close, and the full supply voltage will be given to this. And during starting condition, so this will be closed and this will be opened. Okay, normally open contact will get closed. Normally closed contacts will get open. So if it is open means, so what is the here? This contact is open. Then what will happen? The supply will flow through this only. Okay, and it will be included this windings. And this normally open contacts gets opened, and the normally closed contact closed means what will happen? So this entire portion of the windings will be removed, and the full supply voltage will be given to the auto transformer. So this is the case. So you have to remember what is the de-energization and the energizing. So energizing represents that you are trying to close the contact. De-energizing represents you are opening the contact. Okay. So that is the meaning. Are you clear up to this auto transformer? So you can explain the basic. This terminal is where you are keeping this terminal. It represents what is the portion you are going to include. And when you will change these positions means, so you will change these positions during off condition. And during on condition, you are not supposed to change this position. You won't change it generally. Because the role of this off starter is, so you are avoiding the movement of any contacts during operation. Okay. Okay, this cap setting you can do at the ideal condition. You can set at the 50% or 65% or 80%, and that will be included in the starting condition. Once when the motor attains rated speed, so you are removing the total windings from the circuit, and full supply voltage will be given to the induction motor. So when this contact is closed means automatically this contact will get open. Okay. Are you clear up to this? So next will be the path winding. So this is a new concept we are going to consider. So this method represents that so motor winding will be splitted into 2 or more separate sets. So we'll discuss in the further classes that in the module 3. So we'll have a squirrel cage rotor, double cage rotor also we'll discuss. Double cage. We will have the 2 cages induction motor. 2 kg. There is a two different rotor. Okay, in the same motor. So we'll have a single motor. In that you will have the two different cages. So one cage will have one property, another cage will have another property. That is the R and X. So similarly, here we have the two or more windings, separate set of windings will be available in the motor. Okay. So during the starting condition, one set of winding will be included. During running condition, another set of winding will be included. So what may be the property of the winding means? So during starting, if you are including one set of winding means, so that winding will have more resistance, less reactance. That winding will have a more R value and less X value. So what is the need of having higher R value means? So the resistance, okay, suppose if you are having one set of winding, so this you are going to include during the starting condition. You can see the board, okay, during the starting condition, if you are using this winding means, so this will have a more R value and less X value. And if you are having another set of winding, and this is having less R value, more X value. Okay. So if you are including more R value, it represents you are limiting the starting current. And we are during the starting, we are not worried about the torque. So R is responsible for the control of I, and X is responsible for the control of T. Okay. So what is the R? R is the resistance. So it is responsible for the flow of current. Then X, it related to the torque. So if you are having less X value or more X value, it indirectly represents the what is the amount of torque it is going to be generated during starting condition or during running condition. Okay. So similarly here we will have the two different set of windings, but these starters may be more costly compared to the other starter. But you will have this is the one method. If it is required means you can use this type of starter. Okay. So we are having a two or more set of windings. So during the starting condition, you will connect one set of winding. So it will have the property of resistance more and reactance less. So thereby it limits the starting current. Okay. And next, what you are going to do means once the motor attains 70 to 80% of the rated speed, then you will connect another set of winding. So what is the role of that set of winding means? It will have a property of more less resistance and more reactance. So during running condition, if the resistance is less means automatically the efficiency of the machine will be high. Okay. So during the starting condition, we are not going to worry about the efficiency. During starting condition will be only a fraction of seconds. Okay. So once the motor attains its rated speed, then only we will worry about the efficiency. So during starting condition, we won't we'll add more resistance. So we are not going to worry about the efficiency. During the running condition, we are going to have the lesser resistance. So we have more reactance. So what will happen means the efficiency will be better. Okay. This is the concept. Okay. So there is a here you see the second point. So this setup we have here. So dual voltage. So what is the dual voltage? 230 volt or 460 volt. So will be applied during the starting condition. Okay. And the next will be the star delta. Okay. So this already we discussed. Here we in terms of soft starting, so we are avoiding the mechanical contact. So through the normally open or normally closed contacts, so we'll have change from star to delta conversion. We'll change from star to delta. So what is the ratio of reduction in voltage in the case of star delta starter? What is the ratio of reduction in voltage? What is the amount of voltage you will reduce during starting? Starter முடிக்க போறோம் இப்பயும் ஆன்சர் சொல்லலாம் you cannot write the concept. So if you suppose example if you are applying 415 volt as input voltage, if you are connecting the starter at the star condition during starting condition, what is the amount of voltage you can reduce? எவ்வளவு voltage reduce பண்ணலாம்? Approximately சொல்லலாம். You can post in the chat box also. So applying some 400 or 415 volt as an input voltage. So what is the concept here? We are going to connect the star winding during starting condition, and once the motor attains its rated speed, so we'll connect to the delta connection. Okay. So during the star connection, what is the concept? You are reducing the voltage. During the delta connection, we are going to apply the full voltage. So in the normal star delta starter, we are having the TPDT switch. So through the switch, we'll have the changeover from star connection to delta. So here we'll use the contacts. Okay, we use the normally open or normally closed contact. Through the contact, initially we'll start with the star winding. Then through the contacts, we'll once the motor attains rated speed, so we'll change to delta connection. Okay. Then what is the ratio of changing of voltage during starting condition? Starting condition, what is the voltage? If you consider V is the voltage during the starting condition. During the V is the supply voltage you consider. So what is the voltage it reduced during starting, and what is the voltage we are having during running condition? So the question கேட்டிருக்கேன் நான். ஓகேவா? Anyone can able to answer this question? ஸ்டார்டர்ல ப்ராப்ளம்லாம் போட்டோம். ஸ்டார்டர் வந்து ஸ்டார் டெல்டா ஸ்டார்டர் ஏற்கனவே டிஸ்கஸும் பண்ணியாச்சு. During the starting condition, what is the amount of voltage we are reducing in the star delta starter? Ratio சொன்னா கூட பரவாயில்ல. தம்பி இருக்கீங்களா எல்லாரும்? ஒன் தேர்ட் அபிராமி தான் கரெக்டா சொல்லியிருக்காங்க. இந்த வந்து ஃபார்முலா பாத்தீங்கன்னாலே ஓகே. Okay, one third we are reducing the voltage. Okay, we are giving the voltage means V by 3 is the voltage we are reducing during the starting condition. Okay, so one third of the voltage will be applying so during the starting condition. Okay, so during the running condition we'll apply the full voltage. So this is the concept related to the star delta connection. Okay. So next will be the solid state starter. Okay. So this is a new type of starter, soft starting method. Okay. So we'll have only the solid state devices. We are not having any mechanical component. So all the mechanical components will be replaced by the electrical component. We are not going to have any mechanical component. Moving parts will not be available. No isolator, no switches. It will be no variac will be available. Okay. So here we are going to use, if you want to control the voltage means we are going to use the powertronic device. Okay. So we call that as a thyristor or silicon controlled rectifier. Okay. That mechanical component is going to be replaced with the powertronic component. So we have electronics component. So electronics component will have the limitation in the voltage. Limitation in volts. So maximum the electronic components will be working up to 30 volt. Okay. So what is the maximum value RPS we are having means that is a 30 volt. So less than 30 volts only the electronic components will generally operate. It may work at 5 volt or 15 volt or 12 volt plus 12 or minus 12 plus 15 minus 15. So this is the voltage range of the electronic component. So here we are going to use a powertronic component. It is going to be operate in the power system. What is the voltage available in the power systems? All the voltages, it's almost this electronic device is going to operate. We call this as a silicon controlled rectifier. We will have some more powertronic devices also. Okay. So what is the role of this means? This is going to control the voltage. So we are having the ratio or we are having a fractional control. So everything will be carried out. It eliminates the variac or step change in voltage. Everything it can be controlled by using this SCR. Okay. So if you want to accelerate the motor, if you want to control the motor voltage, if you want to control the current, if you want to control the torque, so everything will be controlled by using this powertronic device. Okay. So this device has smooth variation smooth variation in the resistance. So through the device, so the property of the resistance will be available inside the device. Resistance property will be available in the inside the device. So this device is a controlled device. Okay. So we discussed the diode. Diode is an uncontrolled device. We are not having any control. What is the input we will give? They will get the output. But this silicon controlled rectifier will be a controlled device. We will have a terminals. Gate terminal will be available. So in the diode we have anode and cathode. But in the SCR silicon controlled rectifier we have a 3 terminals will be available: anode, cathode, and gate. So this gate will control the flow of current inside the device. Okay. So we'll discuss the arrangement of the device. So you can see, you consider a 3-phase system. Okay. We have a 3-phase motor. You consider a squirrel cage motor, and you can say refer the arrangement. And this is the 3-phase supply we are going to give as the input side. So L1, L2, L3. So that is the input supply we are giving. What are the arrangement we are having? We are having a fuse, and 2 SCRs are connected in anti-parallel. 2 SCRs are connected in anti-parallel. Okay. And we will have a contact. There is a normally closed contact C1. And we will have a start position and a run position. Okay, start. So C1 will operate during starting condition. C2 will operate during running condition. And then we will have a CT, current transformer, to sense the flow of current in each phase. And then we will have a fuse. Then we will have a 3-phase motor. Okay. So these are the arrangements. So input side will have a fuse. So 2 SCRs are connected in anti-parallel. And we will have a normally closed contact C1. Normally closed contact C2. So we have a start position and run position. And what is the role of this SCR? Means we have 2 SCRs. So AC waveform we have a 360 degree. AC waveforms we have a 360 degree. Okay. So these SCRs will operate only in 2 quadrants. A single SCR will operate in 2 quadrants. So that we are having 2 SCRs. Okay. Suppose quadrant means 0 to 90 first quadrant, 90 to 180 second quadrant, 180 to 270 third quadrant, 270 to 360. We'll call that as a 4th quadrant. So here 1 SCR, this is a unidirectional device. It will not conduct in bidirectional. The SCR is a unidirectional device. So we are having the 2 SCRs are connected in anti-parallel. So it will cover 360 degree. We are having 360 degree. So like this, if we consider this, we will call as a first quadrant, second quadrant, third quadrant, and 4th quadrant. Okay. And with respect to angle, if we represent means 0 to 90, 90 to 180, 180 to 180 plus 60 degree. So like that, it will have a clockwise rotation. And this SCR will often cover two quadrants. This SCR will cover another 2 quadrants. So total coverage will be 360 degree. So that we are using the 2 SCR connected in anti-parallel. So it will have a terminals gate. Okay. So if you consider the SCR means you will have the arrangement like this one. You have the diode with the control element. So diode means like this. We have additional control element. We will call this as a gate. So based upon the gate signals, what you are giving at the gate, so the amount or voltage available across the load can be changed. Okay, based on the number of gate signals what you are applying. So if you want to vary, adjust, means based on the sine wave. If you are considering a sine wave, so if you are applying some gate signal, means it will take the average. The full voltage is supposed to 400 volt. If you apply the gate signal here, you will get 200 volt, 150 volt, like that. So gate will have the control of the output voltage. And here, during the starting condition, what you are going to do means, so here we are not having any reactance or resistance is included here. We are not using any components. So with this SCR only we are going to control the voltage. Okay. So this SCR will have the control from 0 to maximum in the forward direction as well as in the reverse direction. Okay. So that only here if you are applying this during starting condition, the current will flow through the fuse and it will flow through the SCR, and then this contact C1 will close and it will go through the current transformer and fuse, it will go like this. And here through the gate signal we can control the voltage. It is like similar to a if you are having a fan, ceiling fan with the control. What is the control? We are having a regulator. So if you are keeping the regulator at the 0 position, it represents that you are not giving any input to the motor. Fan வந்து எந்த இன்புட்டுமே நீங்க கொடுக்கல. If you are keeping at position number 0, and if you are rotating at first position, second position, third position, fourth position, fifth position. So fifth position represents you are applying the full voltage to the fan or appliances. Okay. So same principle is applied in the SCR also. So in the SCR, it will follow similar to a regulator. So a regulator we are manually controlling. Okay. Regulator we are manually controlling. But in the case of this SCR, we have a closed loop control. Automatically it will control. Or manually we can operate also. Manually, externally we can operate. Physically we can rotate the part. We have a part. Okay. And if we rotate that part, means what will happen? So the resistance or the flow of voltage can be changed. Okay. So you can assume a SCR similar to a regulator available in the fan. Okay. So based on the, here we have a 5 points alone. Regulator வந்து ஒரு 5 பாயிண்ட் தான் இருக்கும், 5 பொசிஷன் தான் இருக்கும். But in SCR we can have a stepless control. Okay. So we can have in between 4 and 5 also we can have the another position. Okay. Similar to a varier. So that is the role of this SCR. So through the gate signal, so we can control the output voltage. So during the starting condition, so based on the position of the gate signal, okay, what is the amount of gate signal you are applying, and the amount of voltage can be obtained across the output. Okay. So once the motor attains its rated speed, so what will happen? So C2 will be turned on and C1 will be gets open. If you open C1 and if you close the C2, what will happen? This fuse SCR will be removed from the circuit, and the current will flow through input and it will flow through the C2, and you are bypassing the fuse SCR and C1, and through the current transformer it will flow, the current will flow to the induction motor. So this is the advanced type of starter. Okay. So initially what you are going to do means initially we will close the C1, so the C2 will be gets opened and the full supply voltage will be given to the induction motor through this SCR. Okay. So if you are, what is the amount of voltage you are going to apply, that will be decided by the control circuit. That is the control circuit represents the SCR circuit. Okay. And gradually you can change the voltage, and if apply the 80 to 90% of the voltage means, then what will happen? You can close the C2 and you can open the C1. Then a full voltage is similar to D-volt starter, full voltage will be given to the 3-phase motor. Okay. And if you want to stop the motor means what you are supposed to do means, and it will be run at full speed. Then what you have to do means, you have to again turn on the ST1 and you have to turn off the C2, and gradually you have to control the SCR, and you have to bring the voltage to 0 voltage, and then you have to stop the motor. Okay, are you clear up to this? So these are the topics you have to write. So if it is asked in the 5-mark question, explain about the soft starting methods means, you can draw this last diagram. The last diagram போட்டு explain பண்ணிடலாம். Solid state reduced voltage starter. And if it is asked in 12-mark or 15-mark question means, you have to discuss all the types of starters. Okay. All these type of starters comes under types of soft starters. Okay. These up to 4 starters, we are not using any powertronic device. So in primary starters, we are not using any powertronic device. So these 4 starters, we are not using any powertronic devices. So we are using normally open and normally closed contacts, and we are having a changeover from voltage positions by simply closing or opening the NO and the NC contacts. So in this last case, so we'll use a Poltronic device. Okay, starters with the Poltronic device will be a purely solid state starter. So these remainings may consider conventional starters will not have a. So what is the conventional starter means? Conventional starters will not use this normally open or a normally closed contact. This will not use. Okay, and if we some starters will use this normally open and normally closed contacts, and we are not using Poltronic device. Poltronic device we won't use. Okay, and here we'll use both Poltronic device as well as the normally open and the normally closed contact. Are you clear with this? With this, we are almost completing module 2. வேற டவுட் இருக்குங்களா இந்த ஸ்டார்டர்ஸ்ல? No. Okay. With this, we are completing the module 2. So in the Google Classroom, you can refer. So in that, we'll have the question bank. Okay, question bank will be available. For unit test, you can go through that question bank. In that question bank with the answer key is available. Okay. You can go through that. So if you are not having doubt, means we'll solve some additional problem. There are doubt on the KLS starter. So you have to remember what is the conventional starter and soft starting methods. So you have to clearly read the question and then you have to answer. So either conventional starter are asked or you are supposed to write soft starting method. So you should be clear with the question. Then you can proceed. If you are writing instead of conventional starter, if you are writing soft startings, you won't get passed. But you have to remember and you have to keep in mind. So in the module 2, so these are the topics for the unit test: construction of auto transformer, principle of operation, copper saving, applications of auto transformer, construction of three-phase transformer, three-phase transformer connections, parallel operation of single-phase and three-phase transformer, off-load and on-load tap changing of transformer, and AC voltage regulator. So இது ஃபுல்லா வந்து யூனிட் டெஸ்ட் இப்போ இருக்கிறது. ஓகேவா? And second half of second module வந்து construction details of three-phase induction motor. நம்ம என்னென்ன டிஸ்கஸ் பண்ணியிருக்கோம்னு சொல்லிடுறோம். Construction details of three-phase induction motor. ஓகேவா? Types of rotor. So construction squirrel cage, slip ring. So types of rotor, principle of operation, slip torque characteristics, equivalent circuit of three-phase induction motor, torque equation. Okay, torque equation is starting torque, running torque, maximum torque during starting condition, maximum torque during running condition, condition for maximum starting torque, condition for maximum running torque. Everything we discuss in the torque equation. Next condition for maximum torque, losses and efficiency, starting methods, soft starting of three-phase induction motor. So this is the second half of module 2. Okay, so we covered up to this. From next class, we will move to the module 3. So now we will solve some additional problem. So in the previous class, we solved some problems. If you're having any doubt, means you can ask. If not, means we'll move to the next problem. This is example 5 we discussed. Okay. So you take the fourth problem. Yeah, 5 HP, 3.73 kilowatt, 400 volt, 3-phase, 50 hertz cage motor has a full load slip 4%. Sorry, 4.5%. The motor develops 250% of rated torque and draws 650% of the rated current when thrown directly on line. What would be the line current, motor current, and the starting torque if the motor were started by means of start delta starter and auto transformer starter? So write the given data, we'll solve the problem. To write the motor specification, ISP, input voltage 400 volt, 3-phase, so frequency 50 hertz, and the full load slip is 4.5%. The motor develops 250% of rated torque. And draws 650% of rated current. So these are the parameters during DOL, direct online. Then we have to solve for star delta and auto transformer. So you are going to supposed to calculate line current. Line current you are supposed to calculate, and the motor current, and starting torque. Okay. The first we will consider about star delta starter. So as per the given data, so we are having, so slip, you consider slip equal to, so 4.5%. So motor developed rated torque. So rated torque is equal to 250%. The rated torque. And rated current. So rated current is 650. So 650% you consider this as a 250 and this as 650. So it is given in terms of percentage. You consider as a whole value. Okay. So first we'll solve for the star delta starter. So you are supposed to calculate the line current. So line current. So line current is equal to 1/3 of rated current. 1/3 of I rated. What is the 1/3 of I rated? 1/3 into 650. So if we solve means you will get 216.7%. Okay. And this is the first one. So you see the first problem, the next problem you can try to solve. Okay. So next is motor current. So this is during starting we will have this star connection. So I line is equal to I phase. So motor current and line current will be same. So we will get 216.7%. Okay. And so next, so what about the third one? The third one will be the starting torque. So starting torque is equal to rated torque given as the 250 divided by 3. Okay. And they will get 83.3%. And here you have to use this 1/3 because the given starter is a star delta starter. So remaining parameters are given in order to confuse you. So we have given some voltage and we are given some kilowatt or HP is given. So that is all not required to solve this problem. So slip is also given. All this data are to confuse you. Okay, you have to use this formula. You are supposed to, by using this data, you are supposed to calculate line current, motor current, and starting torque. So rated torque and rated current is given. So rated torque is 250 and the rated current is 650 given. Okay, and you can use the formula directly. Line current is equal to 1/3 of the rated current, and this motor current you can give as line current is equal to phase current because star connection, and the starting torque again you can consider that 1/3. So can you try for auto transformer starter similarly? Here it is given as 1/3. So this parameter alone will change in the auto transformer starter also. Okay, and again you try to solve. So this parameter is actually this parameter. This rated, I will give a clue also. So line current equal to 1/3 of the rated current. So what is the line current? This is the starting current. Starting current is equal to 1/√3 squared. Generally 1/√3 squared into I full load, that's rated. Okay. This is the line current. Line current indirectly we can represent as starting current. That is equal to ratio. So it is a star delta starter. What is the ratio we are having? 1 by root 3 squared into full load. This full load is otherwise again called as short circuit current. Full load otherwise we will call this as a short circuit current. So like this only generally we will derived 1 by root 3 வந்து நம்ம 1 by 3 into IAC ன்னு போட்டிருப்போம். Okay. If you refer the starter equation, you will have this equation. I starting is equal to 1/3 of I short circuit current. That's the line current equal to 1 by 3 I rated. So you may have the term rated or short circuit or full load. So starting or line current. Okay. And similarly, you try for auto transformer starter. You can refer the same equation. What is the changes in this equation for the auto transformer? You have to identify. The equation identify பண்ணிட்டீங்கன்னா you can solve remaining things. You try to solve for auto transformer. Okay, Venkatesan correct value. Correct. 234 is correct. Motor current மட்டும் உனக்கு small motor current வந்து change பண்ணும். How you calculated 234%? You divided by 3. How ரெண்டுமே சேம் போட்டுருங்க. Both will not be same in the case of auto transformer. Okay. Here these both the currents are same. Auto transformer starter are as per the star connection. So line current and motor current are same. So you are here we are getting the same value. But in the auto transformer starter we have a small changes. So line current and motor current will be different. Okay. So for the first case, so line current okay. Venkatesan, motor current மட்டும் I will write the formula after you can calculate. So line current K squared into ISC. Okay, you calculate பண்ணிருப்பீங்க. What is the K squared? 60% it is given. 60 divided by 100 whole squared into short circuit current 650. Okay, this is the first step. This is for the auto transformer starter. This is for auto transformer. So for this, you will get a 234%. Okay, and motor current, second one. So motor current equal to K into ISC. So this is a line current, this is a motor current. Okay. So in the case of auto transformer starter, so here we have a K squared into IC and the motor current K into ISC. And similarly, starting torque T starting is equal to, so again K squared into 250. K squared into T full load. That is a rated torque. So 60 divided by whole squared into 250. So this is a small change between the line current and motor current. Star connection, star delta starter will have the based on this equation you will get the same value of current. Line current equal to phase current. So these two currents will be same. But if we come to the auto transformer starter, so we have a general formula. So I starting is equal to K squared into I short circuit current. Okay. And motor current instead of K squared, here you will have K into ISC. So what is this value? Motor current. You tell the value for motor current and 390. Okay. Correct. 390 and starting torque. What about starting torque? இங்க நம்ம சால்வ் பண்ற எல்லா ப்ராப்ளமே will have a different model. The same model maximum solve பண்ண மாட்டோம். So note down the difference alone. Okay, you will have common formula for each and every problems. You will have a new formulas. Okay, that you got to note down. 90%. Okay. So third subdivision 90%. Here remaining parameters given are to confuse you. So you choose the correct formula. Here additional data கொடுத்திருப்பாங்க பாரு ப்ராப்ளத்துல 5 HP 3.73 kilowatt 400 volt 3 phase அப்புறம் 4.5 full load slip இதெல்லாம் கொடுத்திருப்பாங்க அதனால நீ கன்ஃபியூஸ் ஆகாத so you can identify this formula and it will be easy to solve. புரியலனா போர்டுல பார்த்து காப்பி பண்ணி வச்சுக்கோ அப்புறமா கோ த்ரூ பண்ணினா you can able to understand. Shall I move to the next problem? Are you having any doubt in this problem? Doubt இருந்துச்சுன்னா unmute பண்ணி கேளு. நீ தான் எக்ஸாம் எழுத போற ஃபேக்கல்ட்டி எழுத போறது கிடையாது எக்ஸாம். இப்போ CA2ல உனக்கு இப்போ என்னெல்லாம் நடத்திருக்கோமோ மேக்ஸிமம் கிளாஸ்ல என்ன ப்ராப்ளம் போட்டிருக்கோமோ அதுதான் வரும் கொஸ்டின் பேப்பர்ல. நெக்ஸ்ட் ப்ராப்ளம் போயிடலாமா? ஓகே. இந்த ப்ராப்ளம் நீயே சால்வ் பண்ணலாம்னு நினைக்கிறேன். ட்ரை பண்ணு. இதே மாடல் நம்ம நிறைய ப்ராப்ளம் சால்வ் பண்ணிட்டோம். So determine approximately the starting torque of an induction motor in terms of full load torque when starting by means of star delta starter auto transformer starter. From data kuduthirukkom short circuit current of the motor at normal voltage is 6 times the full load current. So that's short circuit current is 6 times the full load current and the slip is 4%. To write the given data, so K value on the 70.7% K. So in terms of value எடுத்தீங்கன்னா 0.707 வரும். So that value is given. Next short circuit current is equal to 6 times the full load current. Next slip is given 4%. So இந்த மாடல் ஏற்கனவே நம்ம சால்வ் பண்ணிட்டோம். You tell only the answer. Already we discussed the formula, everything we have discussed. You can refer the what are the problems we solved and you try to tell the answer. What is the answer needed means you are supposed to tell starting torque to full load torque equal to what is the value for both the starter. Starting torque to full load torque சொன்னீனா அதுல starting torque வந்துரும். For star delta starter 0.48. Okay. Okay, correct. Okay, correct. Auto transformer, correct. So you are supposed to calculate starting torque to full load torque. The formula இருக்கும். So what are the starters given? So based on that you will get the formula. So it is 0.48. This is for first case is for star delta. Now what about the second case? Starting torque to full load torque is equal to 71.9. So finally you have to write like this. This is for auto transformer. Finally you have to write. So you are supposed to calculate starting torque. So starting torque equal to 48 times full load torque. So this if you are writing in terms of percentage means you will get 48%. And this you are getting in terms of percentage means 71.9 or 72. So here also starting torque is equal to 71.9 times full load torque. So finally you have to write like this.
சார் மீட்டிங் இருக்குன்னு சொல்லியிருந்தீங்க சார்.
ஓகே சார், ஓகே. நீங்க பாத்துக்கிறீங்களா?
ஓகே சார். நான் அந்த ஃபீஸ் பத்தி பேசுறேன்.
ஃபீஸ் பத்தி இது 48 times னு போடும், 48% போடும். Here we are representing in terms of percentage only. So this is instead of times you put percentage. So finally you have to write like this. So நீங்க கண்டினியூ பண்ணிக்கங்க சார்.
ஓகே சார்.
சரி சார்.